Welcome to all another video on urban hydrology. So in this video I have brought you a case study example of a sag point, local sag point in a road section and how it affects the localized flooding of in surrounding areas. So this example is for Bengaluru's Brigade Road area where there is a local sag point, road sag point is there, and there is no proper drainage systems are installed. So that due to that reason, so it is keep on getting flooded even for the small storm events. So this picture what you are seeing are the aftermath effect of the flood. So during this storm, when the small rain event occurs, the street gets flooded, and this is that image. Okay, this image I taken twice. So first on the 12th of September 2023, and next is on 20th September 2023. So this you can see streets are completely got flooded. Okay, so and the depth of water is almost like 20 centimeter. You can see 15 to 20 centimeter depth of water which has flooded this street. Okay, because this part of this section is on the local low point. This section is around this depth, this flood, this specific flood inundation concentrated to around 50 to 80 meters surrounding area, because that location is at lowest point, and the surrounding this all the runoff from this building and surrounding building all directly discharged into the street. Okay, as a free flow. That is the reason the streets are getting flooded for a specific location. And you can see this is the situation of the inlet. So some vents are provided to evacuate this storm discharge, but still it is insufficient. Okay, and I will show you how to design inlets to mitigate this flooding. Okay, and this is actually the location where I was mentioning that the flooding is happening. Okay, it is near the Patrick Church, near Brigade Road. Okay, so there are two vents are there. So this vents you can see where I marked, no, this near this road curb. Okay, this is the location where the floodings are occurring, because these are located on the road sag point. So that is the reasons from here the surrounding area, all the road runoffs from the land runoff directly discharge into the street, and it doesn't have any proper drainage system here. So my task is to, or the objective of this video is to design gully inlet or a catch pit at these locations. Okay, so for that I need to trace the actual catchment which contributing the discharge at this location. So this I brought you the hydrology and the sag point. Okay, so this is actually I have approximately traced the catchment. So which you can see in the cyan color is the approximate catchment, and this is actually the drainage sag point. The red color circle is nothing but drainage sag point where the flood water is getting accumulated. So the road is having the cross slope on either side. So for this case study I want to show you a sample analysis of proposal of a sag point inlet. Okay, so here I am considering only the left part of the road. Okay, so here I have traced all the offside and inside road runoff. Okay, so the road runoff I have traced this catchment, so it is around 0.6 hectares, and the time of concentration from the Kirpich method it is around 10 minutes. Okay, and I am designing it for 10-year rainfall intensity, that is 140 mm per hour, and the coefficient of runoff I am considering the 0.9 because it's a fully urbanized area, and some minor traces of the tree coverage you can see. Okay, and the peak discharge I computed from the rational method is 0.21 q max. Okay, so for this case what I will do, I will propose this location. These are actually lowest point, so I will propose the lowest point, the sag inlets. Okay, so the sag inlet type would be reticulin. Reticulin means honeycombing type of opening it will be having. So I will show you this reticulin type of the grate inlet. So this is the type of grate inlet which I am going to design and show you the sample calculation using this hydraulic toolbox software. Okay, so let's start that the tutorial video on the hydraulic toolbox software. Before going into the hydraulic toolbox design, I want to explain you about my strategy. So what would be my strategy? So if you can look into the catchment hydrology, so I'm getting a peak discharge of 0.21 Qmax. Okay, so looking at the situation, even if I propose a double inlet, so I can't intercept almost this much of the flow. So what I need to do technically or practically, I need to propose two inlets, so that is on the on grade. So it is grading, the road grading is such a way that this is actually a sag point. Okay, and the rainwater runoff from the two side of the road and converges at this sag point. Okay, I have drawn that with a simple sketch. So here you can see there are two on grade, so it is on the slope and this is on the slope. Okay, from these two sides the finally water the flows and accumulate at this location. What I shown is yellow is the sag point inlet. Okay, there I am going to propose my sag inlet. Okay, so I will just tell you about the flow direction tracing here. Okay, I'll use this pen tool. Okay, runoff from this part of the road and the surrounding area. So surrounding area means this commercial buildings all initially come into this inlet. Okay, whatever the runoff which is untraceable, or you can say the bypass runoff, will finally goes into the second insag inlet. Okay, same on other side. Okay, from another side the same scenario will be happening. Okay, this is actually the road runoff and the surrounding runoff, whatever the captured by on grade inlet, finally it comes in and accumulate on this insag inlet. Okay, so what I will do, I will propose total 3 inlets. Okay, two on grade and one on the sag point of the road. Okay, this is my strategy. So applying this strategy in the hydraulic toolbox calculation for the computation of the inlet sizes. So what will be the sizes of the inlet and how much inlet I want. Okay, so let's do that in the hydraulic toolbox software.